your move here to get the answer. It looks like it's nonsense right now. It looks like, no way. If you want to have an idea of what you could do, though, to make this work.
Do you add them together?
Okay, and when you say add them together, tell me more.
The 23 pi to 36 and pi.
23 pi to 36 and the pi over 9. And we'll put them together. Are you thinking about a formula?
Yeah.
Okay, now the formula, we got it, is the sine of, help me out here, a plus b? Is that the formula you have in mind?
Yes.
Okay, if it is, if that matches up with sine a plus b, she said, Professor, that was sine a, cosine b, plus cosine a, sine b. And I think she's telling me that's what she's thinking about doing there. Guys, you agree? Does that, in the black there, match up with that formula? If it does, we look at some strange numbers. She's telling me, Professor, it matches up. So this should be equivalent to, all that in the black, should be equivalent to, this is the A, plus the B, sine A plus B. Put those two together, the common denominator of 36, guys, and do it quickly. I think you end up with sine of 27. When you put them together, pi over 36. Yes or no? That 27 pi over 36 reduces down into, look at this, I think that fraction will reduce down by 9 into 3 pi over 4. And see if you guys agree. Is it? Now it takes me right back to the unit circle. Now you finish it up. Does anyone recall 3 pi over 4 in quadrant 2, the sine, the y coordinate? What's the sine of 3 pi over 4? Go back on the unit circle now. What's the sine of pi over 4? Radical 2 over 2. And after all that work, there's the answer. That's a formula. I thought I'd throw in one more just to make sure we understand how to connect here and find a formula that may meet what we need here. This one was like this: cosine squared, you got pi over 12, subtract sine squared, pi over 12. And we want to evaluate or find an answer for that. Does anyone think they know of the formulas well enough at this point to tell me, is that a formula? Can I make that match up with one of the formulas? And it looks like it might be cosine squared theta, I guess. Subtract sine squared theta. Please tell you guys, is cosine squared minus sine squared, is that one of the formulas we discussed on Monday? If it is, there's a formula for, I think, cosine what? Double theta? There's that formula. Therefore, that in the black, since it matches up, can be written as merely this is same as saying cosine double pi over 12. Which now comes out to be cosine pi over 6. And that takes me right back to the unit circle, and cosine, the x-coordinate on the unit circle at pi over 6 is radical 3 over 2, and that's the answer. Now, can we do this? I hope so. Some students are telling me they're concerned about the final exam. I was always concerned about my final exam. Some students need a good score on this. Because when I put everything into Canvas, Canvas is going to tell me what the grade is. Not Ramsey. Ramsey is going to look at Canvas to see what their grade is. But you need a good score. Many of my students are close to another grade. It's going to take a good score in that final exam. Guys, any concerns here? Just matching something up with a formula. And we go from there. I thought I'd point that out before I jump into this chapter 7, finish it up. Yes, one more thing here. That's part A, part B. Let's say C. Let's try to solve equation, and I brought this equation in. Cosine double theta is equal to, no, hang on now, plus sine theta is equal to equal to 0. So guys, cosine double theta plus sine theta is equal to 0. And I want you to find all the answers possible in this interval from 0 up to 2 pi, and let's not include 2 pi. Now, does anyone have an idea, as we sort of close this down, is this a formula type also? If I'm discussing formulas, is there a place on here to use a formula? You have cosine double theta. And one of the formulas for cosine double theta I used over here. It's cosine squared minus sine squared. I'd prefer, if I could, if you guys remember, was there also one that has sine in it? Because I see a sine out here. Does anyone recall what the other version looked like? That has sine. I've got cosine squared minus sine squared. That's the one I'm accustomed to. But I could play around with this and end up with another version with only sine in it. Does anyone remember what that one looks like?
1 minus 2 sine.
1 minus 2 sine squared theta. And of course, still got plus sine theta. Got to do the formulas. It's equal to 0. Now, everything's in terms of sine. How do we just rearrange it? Looks better in this order. -2 sine squared theta plus sine theta plus 1 is equal to 0. Just rearrange the terms. I don't like that negative sign stuck out front, so let's multiply everything by negative. Rearrange it now like this. Multiplying through by a negative. And you have now this original in this form. Now, can anyone tell me, now since I have down here, what would you suggest I do? Who has an idea? How can I finish it up?
Let u equals sine theta.
That's what's going to be a quadratic. So let u be, Michael, absolutely, yeah, let u be sine theta. If you do, he's telling me this now becomes 2u squared minus u minus 1 is equal to 0. This looks so much like an exam question. So much like an exam question. Now you're into middle school, this was factored. Takes you right back to middle school. To u, should make sure minus 1, I think goes there, plus 1, and you do your factor. Split this up, guys. Looks like, if all this is correct, u is -1/2, and u is equal to 1. And Michael said u was representing sine theta, so let's put sine theta in here with that u substitution. And down here, sine theta equal 1. Now, can anyone reflect back to the unit circle? It always goes back to the unit circle. Where have you seen the y coordinate equal to a -1/2? And I'm asking if I find all of them caught between 0 and 2 pi. That's 1 revolution of the unit circle. Anyone tell me? And by the way, we're assigned negative to begin with. Which quadrants? The y.
3 and 4.
3 and 4. So the answer is, there's one answer in 3 and there's one answer in 4. Does anyone recall the angle down in quadrant 3, whose sine is -1/2?
7 pi over 6.
I'm in a possibility here. Now, we said also quadrant 4 could be considered because sine's also negative down in quadrant 4. Does anyone remember the size of the angle in quadrant 4?
11 pi over 6.
That's 5 or 6. And those are the two that I can use there. Also, don't forget, it says also you could consider this. Where is sine 1? Where on the unit circle have you seen the y coordinate sine equal to exactly 1? Pi over 2. And therefore your three solutions are, I don't care what order you place these guys, 7, 5, or 6, 11, 5, or 6, 5, or 2. Close that up. And those are your solutions. This test is going to be something else. This test is going to be something else. This handout, or two handouts, that you're going to be working on this weekend is going to be something else. Guys, any concerns here? At all? Okay, just try and close this down before I go into chapter 7. Now, it looks like, yeah, I got to do one more line here. Part D, I'll squeeze it in up here. Given this information, secant theta is equal to 3. Comma. And tan theta is less than 0. Looks like that. Find that information. Sine of double theta. Anyone first tell me, does this sort of remind you of, was it a quiz or the last exam? Probably both. Does it sort of look like some of those questions on that last exam? Except I think on the last exam, it would be asking you to find sine theta, not double theta. So that means here, you want to use a formula. Guys, first, what's my formula for sine double theta? I'll put that here, since I need to use it. So the 2 sine theta cosine theta. Okay. Now, here goes. If I should in the instructions say use identities to find the answer. From the given, anyone tell me they gave secant is 3, tan is negative, let's find out which quadrant we're in. Secant is 3, guys. Where is secant 1 over x of the 4 quadrants positive? This is a positive 3. 1 and is it 3 or 4? 4. You guys agree? Quadrant 1, quadrant 4, is that where the x is positive? 1 over x would be positive. Now where is tan negative? Quadrant 2 and quadrant 4. You guys agree there? Where am I then? I'm in quadrant 4, which means my coordinates, being careful, are those, positive, negative. Wow. Okay. Now let's see what's going to happen here, guys. Can someone tell me a start? And we'll do it. And let's try to use identities in my approach here. Does anyone have an identity? Sine squared plus cosine squared. 1 plus tan squared is equal to secant squared. Those types. Tan is equal to sine or cosine. What can you use here? Based on the given. And this one's just staring at you. What do you think would be an appropriate identity to go to based on the given to get a start?
Cosine is equal to the reciprocal of secant.
I could. Here we go. Okay, so on the side here, you're going to tell me cosine quickly. Michael, since secant's equal to 1 over cosine, they're reciprocals, it quickly be secant, which is 3, flipped over, 1/3, like that. That means I can quickly put in 1/3. Is that true? Now I need sine theta. Now what identity could I turn to if I wish to find sine theta? Now guys, let me put a semicolon here. Michael was thinking about this for the first one. That's where the identity was expressed. Now can you want to tell me an identity maybe that would help me find sine? And I'll take it back here, put it in, do my math, I'll be finished.
Sine squared plus cosine
There
squared
you
plus
go.
1.
Sine squared plus cosine squared equal to 1. And In this case, that's sine squared. I'll get out of your way here in a second. Cosine squared, guys, cosine's 1/3, that's 1/9. You know how to do that. This is 1. We end up with sine squared. Move that 1/9 over, subtract it, that's 8/9. Do a square root. I gotta be careful here, when I do a square root, that 8 is gonna be 2 radical 2, it's not perfect, over 3. Now, which quadrant am I in? I'm in quadrant 4, and I'm doing a sign, which is why. Should I prefix that with a negative sign? Because I'm in quadrant 4. There's sine theta. Done there. Since it's done, I can put it right here. -2 radical 2 over 3. Jeez, where's the 2 out front? Final answer, I don't mess up here. Guys, it's a 4 radical 2 over 9, I think. Step back and look back on the one I talked about. Not 4, is it? It's 2. Is it 2 radical 2? Step back. Look at it. No, it is 4. And it is negative. Is that it? -4 radical 2 over 9 is the final answer. It's been a long time since I've seen a perfect score in the final. But with the number of students who had a 80 out of 80 on that last test, and those 3 students who got that math 8 extra credit, I should have some students in here who get a perfect on the final. All classes this class. Okay, guys, I want to do that. That's going to close it down. Make sense the way we approach this? Okay. Now, part 2, chapter 7. I'm going to make chapter 7 as brief as I can. And what they do is, in chapter 7, they ask us to do this. Please go back to middle school and look at the trig using right triangles. You guys will do this. Let's make it as simple as we can. So let's go back. And the way I'm going to start this is we'll go back and look at the unit circle that we had earlier. I'll work with before. There's my unit circle. I'll place an angle in quadrant 1 to get a start, and have that angle to look like this. And place a point. And that point should have coordinates. I always call it x, y. Maybe 1/2 radical 3 over 2. It might be radical 2 over 2, radical 2 over 2. That has coordinates. I'm just calling it x and y. Now, guys, let's assume that we're a unit circle, that would be true. What I want to do, though, to move into chapter 7 is crash this down, go back to unit circle, look at it again, but this time, drop a perpendicular from that point down to the x-axis. And form a small right triangle. That. And that hypotenuse, so we'll call it hypotenuse, this right here was on the unit circle a length of 1, wasn't it? That's the unit circle. Now they're saying, please open that up and just call it a radius. Is it also a radius of the circle? It's called R. That'd be some number. Could be 1 again. 2, could be 3, some radius, and call this side x, and since I put it in orange here, call this y. And now with that set up, please now redefine all 6 trig functions. So when I say redefine, guys, put theta right here in the corner. Now the the side here, sine theta. Look at this. We are accustomed to, for sine theta, what's sine theta's definition if you were on a unit circle? If that radius was 1, you'd quickly say the definition for sine is y. That is when I consider, look at this, right, like y is 1. That is when I consider the radius to be a 1. Now the radius is opened up, so I'm going to open this definition up into, look at this, guys, y over r. That radius may be something different than a 1 now. And then from middle school, they do this. They give names for those variables. They call y, look at this, and you guys probably will recall this. Y was considered the side opposite the angle. So let me just abbreviate. So y is acting as a side opposite theta. R, of course, definitely is the hypotenuse. Like this. Strange word, hypotenuse. And X, they identify as adjacent. The adjacent side, side next to. And I think many students in class have seen this, probably back in high school or middle school. So we got an opposite side, a hypotenuse, and an adjacent side. Is that true, guys? So now if I accept y over r, I open up the radius to be something other than the 1. As my new definition for sine, I could say, wait now, could I also call this, professor, the opposite side, the length of, the opposite side, guys, we'll just abbreviate here, over r, the length of the hypotenuse. And there's your definition of sine that you saw back in middle school, where we did the unit circle. I took it back to middle school. Opposite over hypotenuse. That's my new definition for sine. Number 2, cosine. We, on the unit circle, are accustomed to this. X. I could think of x as x over 1, where that 1 was acting as the radius or hypotenuse. So guys, this becomes x over r if I open it up. Now the radius could be something other than just a 1. X, length of the adjacent. Make it real quickly here. The adjacent side compared to the hypotenuse. The length of both of those for cosine. Tangent, we are accustomed to this. Tan theta. We're accustomed to y over x. Oh, this one fits nicely. Now in chapter 7, it says, if you use the right triangle, it's asking us to please. Now, think of this as tan is y over x, well, that's opposite. The opposite side compared to the adjacent side. I think this is what you guys saw back in middle school, wasn't it? Whew. Now, I had a student tell me, I had never heard of it before. They, in class, were using a word called SOHCAHTOA. I thought they were saying something bad about me. I had never heard that word before. I said, oh no, are you saying something bad about the professor? The word didn't sound too good, SOHCAHTOA. And they said, no, professor, it's something I saw back in middle school to help me remember this. Now, I don't know, guys, I don't know whether I should even mention it. I think, let me see if I can get this right. SOHCAHTOA. Is that what you guys were doing back in middle school? Now, if you had not seen this, I had never heard that word before. And all of a sudden, they told me, the professor, my middle school teacher says, S for sine, O for opposite, H for hypotenuse. So sine is opposite of hypotenuse. And my teacher back then, professor, says this part could be thought of as for cosine, C for cosine, A for adjacent, h for hypotenuse. I've never heard that before. And the t, tangent, can be thought of in that expression as opposite over adjacent. If that would help you, I don't know. Have you guys heard that word before? Middle school does strange things. Okay, SOHCAHTOA, walking down the hall, SOHCAHTOA, I go, whoa, I've never heard that before. And basically that's what we're doing here. Now, by the way, there's 6 strict functions. I did not do cosecant. If you want cosecant, you know what cosecant should be? It should be the reciprocal sign. So if you flip this over, cosecant can be expressed as what? Hypotenuse over opposite. If you want secant, flip this one over. If you want cotangent, flip this one over. Okay, so that's what we're dealing with. Now, let me see if I'm ready. Michael, my class has a handout from last time. Alicia, did you find your handout?
I have a copy of it.
You got a copy there. Alicia, let me see yours just a second so my students will know which one I'm looking at. Guys, I gave you this last time, and it has a few little triangles at the bottom. You have a copy of this. I gave you a copy of this. You have it from Monday. And then there's another side that we're going to look at to finish up chapter 7. This is chapter 7. One page. We'll finish up chapter 7. Okay? Michael, since you're close by, and I'm looking at Alicia's paper here, yeah, I did have a couple of triangles to solve, find missing parts for. Michael, I think, let me go on the side here, I think I had the first triangle to look like this. And then I gave you some measures. Work with it. Michael, I had right angle here, I think.
Yes.
Did I call that capital C?
Yes.
Okay. And where was A placed? Capital A.
Top left.
At the top? And B here, of course. Now, guys, in mathematics on these triangles, I use capital letters for the angles, the measure of the angles, which are real. We will identify the length of the sides as lowercase letters, opposite the capital letter. So this is gonna be lowercase c here, this is gonna be lowercase b here, opposite b, and opposite a, lowercase a. So lowercase is for the lengths of the sides, capital letters for the angles. By the way, does that say the way it's written? Does that say right now c squared is equal to a squared plus b squared? Pythagorean theorem, the way it's labeled. Okay, Michael, what did I give you guys on that first triangle?
B, lowercase b equals 5.
Okay, this is 5. So it has a length of 5 units. And what else did I give?
Angle B is 20 degrees.
20 degrees. Okay. And then I actually found the missing parts. No problem. No problem. Let me find the missing angle first. Angle A. Guys, angle A must be, and first you tell me before you tell me. What should all 3 angles of a triangle always add up to, sum up to? All 3 angles of a triangle. 180. And in fact, since this is a right triangle, I've got 90 already. So I've got 90 plus his 20, he gave us what, 110? So it's gotta be what, 70? For angle A. That's no problem. Michael, what else did I ask to find?
Just solve the given triangle.
I will find all the missing parts in.
Mhm.
Okay, so angle A is 70 degrees, that's out of the way, guys. Missing is side A. If you want to have an idea of how to approach and find side A, lowercase a. Oh boy. Or lowercase c. And do I have the triangle set up correctly?
You do.
Okay. That's the idea, so express for me the best you can. How would you find the length of segment BC, which has been identified as lowercase a? How should I use? Anyone? Could I use one of these 3? Somehow? Here? sine squared plus cosine squared is equal to one, which is true. So you're saying in my case, a squared plus b squared is equal to one. Is that what you're saying? On the right triangle? Hang on now. All that thought there. You're saying that. Wait, my triangle's leaving. And, b is five, you say now this. Let's see if you read it right here. Are you saying that? And I see right now, if you say that, when you square 5, you got 25. When you move it over to the other side by subtracting, you got -24. And you're gonna try to do a square root on a negative as imaginary. So something's wrong with that rationale. I understand what you're saying, c squared is equal to a squared plus b squared. Did I say this was on the unit circle? Did they identify c as 1? No, so that's why I can't do it. You guys, something else. I'm glad you brought that up, though. What else can I do? Could I use one of those three, the best I can, three basic trig functions with the opposite, adjacent, hypotenuse to work with? And which one would you like to work with?
Lengths of opposite or the lengths of hypotenuse?
Okay, the length of the opposite is A is opposite. And are you looking at 70 degrees? Is that the angle? Okay, she's saying, Professor, I'm going to look at 70 degrees. So we'll take sine of 70 degrees. That's the angle she is looking at, which is sine theta. That's my theta. And it should be the length of the opposite. The side opposite 70 is A. That's what I'm looking for. Over, it says length of the hypotenuse, that's C. Which is cute, which is true. But I think I have two unknowns. Do I? There's nothing wrong. That definition is true. Is that true, guys? But I don't think it's going to lead me to where I want to go. So should I go back and try maybe another trig function, cosine or tangent? What should I do? Are we stuck? This is true, but I just can't do anything with it. What do you think, guys? Well, let's try cosine of 70 rather than sine. I did cosine 70. Let's see what's going to happen. Cosine's new definition is the adjacent side over the hypotenuse. Well, the adjacent side of the side next to 70 degrees is given. Thank goodness, it's a 5. So that's 5 over the hypotenuse, which is C. Now, that's enough for me, if that's correct, do a quick cross multiplication and say the way you will find this, Professor, is C times cosine 70 degrees is equal to 5. Let me step back and make sure all that's making sense. Guys, is that correct? Can we set that up correctly? Adjacent of hypotenuse? Yes, no? The trouble is, I know what you're looking at. Now to find out what C is, or A is, what were we doing here? C, we're trying to find C. Divide through by what? Cosine 70 degrees, both sides. These will cancel, and there's C. It's 5 over cosine 70 degrees. Is that true? Now what's the issue? Aaron, what's the issue? Will we accept that? Have I expressed it correctly? Is it for side C, 5 over cosine 70, when I try to find C? Yes, no? Oh boy, this is a Wednesday. Whew. Okay. Now the only issue is you're taking your final exam, you see one of these. Does anyone know what the cosine of 70 degrees is? I don't. Does it exist? Yeah. I have to refer to Mr. Parker and have him do it for us. So what's going to happen on my test if I have one of these? I'm going to make sure, this is done correctly, that this angle is one that you can recognize and do without a calculator. I wish this has been 60. If this had been 60, you could finish it up. Cosine 60, or cosine 45, or cosine 30. Is that true, guys? You could go ahead and finish it up. I'm going to leave this like this, though, for this particular problem. We can't do anything else with it unless I ask Park to do a calculator approximation of this. Okay, see what's going on? So we got that out of the way. And then find C itself, what would you do from there? Let's say you go and find, we did find C, that's C. How would you find what's missing here? B. Anyone tell me how to find B? Or how would you set it up? Or can we? Can we now use C squared is equal to A squared plus B squared? Whoa. Yes, no, could we? If I knew what this was. Which right now, this would not happen on the final exam, you have no calculator. Okay, now, guys, I brought this in just to show you the setup here. That's all I wanted to look at was the setup and how to find the missing parts, how the missing, a triangle that's given some parts. Now, Michael, was there one more there to look at with the class?
Yes.
Okay, now, was it a right triangle again?
Yep.
Maybe this one will work out a little bit better. This one, guys, from what we've done is perfect. It just means that I would have to turn the part for help. Okay, Michael, let me take a quick glance and see what this one looks like. What's on the other side? We'll see. Looks like this. Mr. Park, do me a favor as I'm setting this thing up. Go ahead and find what this is, would you, for us? Because that bothers me. I wish it had been at cosine 60 degrees and no calculator. Go ahead and find out 5 divided by cosine 70, and I'll get back to it. Michael, how was this labeled? C probably here.
Yes.
Lowercase c opposite. Where's the A?
Left side.
Up here. Capital A for the angle, lowercase a opposite. And of course, B up here, lowercase b here. What did I give for measures there?
Lowercase a equals 2.
This is 2,
Lowercase b equals 8.
8. Okay, this will be a little bit better behaved. Mark, what did you find out for that?
14.6.
14.6.
6. Yeah.
Who on earth would know? He's telling me, this is, hang on now, just a second. So all this, 5 divided by cosine 70, you did all of it for me, right?
Yeah.
And it came out to be, again, what was it?
14.6.
14.7.
6.
6. 5 divided by cosine 70 if you use a calculator still. Okay. Now, let's see what this one is, guys. Missing parts, I am missing, oh my goodness, I'm missing angle A. Here we go. B, Michael, I think I got everything labeled right. B's missing, angle B is missing. Side C, lowercase c is missing. I think that's it. Now, does anyone have an idea of how to find any of those missing parts?
Should you find tangent?
Yeah, I could find, I think I heard what it was, angle, side C, could I find side C fairly quickly? Got to use C squared is equal to A squared plus B squared. Pythagorean theorem. On the side here, guys, I'm gonna do this. And I'm careful, I'm being very careful here. C squared is equal to is what he gave me there. This is 2 squared plus 8 squared. And I think that's 4 plus 64, I guess it's 68. Take a square root. 68 is not perfect. Can be broken down to radical 17. So I do have, this is exact, 2 radical 17, if there's no mistake. You guys agree? Woo! Now, does anyone have an idea how to find either angle A or angle B? We'll put this in. And we may just have to set this up and leave it. But can someone tell me a setup? Let's say to either find A or B, you may want to try to find it. sides of measure of angle A. We use sine, cosine, tangent, based on what you see on the triangle. Go for it.
Use the sine function.
Which one you want to use? You want to use sine, cosine, or tangent?
Sine.
You want to use sine. Now, if you want to use sine, here we go. Sine of angle A, if he has chosen sine, sine's definition is you got to place the opposite over the hypotenuse. So for angle A, which is right there, the opposite is 2. And the hypotenuse was given to me, or we found it, as 2 radical 17. Is that true, guys? Is that opposite of hypotenuse? Which could be reduced down to 1 over radical 17, rationalized radical 17 over 17. Is that true? Now, tell me what I would have to ask Park to do to finish up. We're not finished with that. I think we have right now sine A. We're trying to find A itself. Anyone tell me what would you do now since I have this? How can I find A? The measure of angle A. What would I have to do? I don't think I'm going to ask Park to help me out. What would you have to do? What would I have to ask Park to do? Which I'm not going to ask you to do, because you're not going to have a calculator. What would he have to do on a calculator to find it? We know this. What is A? Is A 20 degrees? 42 degrees? What would you do?
Inverse.
There you go. To find it, I put it down here. I think I got a few there. Got to do an inverse sign on that strange radical 17 over 17. And if you had a calculator, you could do it with the help of a calculator. Mr. Park, what is inverse sine of radical 17 over 17? Okay, look at this.
Uh, 14.0.
Degrees, right?
Yeah.
14.0?
Yeah.
Okay, roughly 14 degrees, guys. That would be, look at this guy, this is A. That's what we were looking for. Roughly 14 degrees. Now, if I accept that, how can I find angle B? All three should add up to 180, right? Or in fact, since I've now not only 2 angles, these 2 angles should add up to what, 90? So I've got 14, so let's take 90, subtract 14, leaves B to be roughly what? Is that 76? I did that quickly. Is it 76, guys? I think. And the triangle's complete. Whew! Is chapter 7 completed? Not quite. Oh, this is gonna work out beautifully tonight. Yeah.
How do you calculate it without calculating?
That's what I'm saying. No, I can't do it. If I ask you to do one of these on the final exam, I must make sure that this came out to be like sine A is equal to 1/2. And you can find that on the unit circle. Or sine A is equal to radical 2 over 2. Good question. I could not ask you to do this without, or using a calculator, but you got no calculators. Guys, making sense? Chapter 7, so far so good? Okay. Now let's do it now, because my summer class is full. And I have a wait list of, I think it's 10. Trying to do the summer class. So if we don't do it, I have no room in my summer class. It's full. Any concerns here, guys? Anything at all? Okay. Now, Michael, was there something else? Did we flip over to the back, or was there something else there?
We suppose.
Flipped over?
Yeah.
Okay, beautiful. Here we go. Now, here's the way we're going, I hope, sort of finish up chapter 7 and get into one of my favorite chapters, chapter 11. Wait, guys, does this bring back fond memories? Oh, I see head shaking no. You guys didn't have fond memories in middle school? Okay, there we go. I think I put all that in, if I'm not mistaken, part two, I guess. Okay, Michael, part three. Tell me though first, because I may have to lead into this. What was the next part asking?
Log, sines, and cosines.
Oh, my Lord. Let's just close it down to chapter 7. I know. Now, I want you to look at something here. If, before I jump in and do what he's telling me to do. If we go across the street, which every semester, I say, please, we gotta do a field trip and go over and visit those kids. I used to know a couple of teachers, but they may not be there now, who taught over there. Guys, let's say you have a right triangle, and I give you, I'm nice enough to give you this. Do something over here, why not? A 3, a 4, and a 5. Am I assured of that those numbers are, that's a right triangle? Is c squared is equal to a squared plus b squared. 25 is equal to what? 9 plus 16. So it's the right triangle. Now, to lead into what Michael wants you to do here, suppose those kids across the street, I'm sure they've done. Suppose the teacher asks them to find the area of that triangle. Now, does anyone recall what would you do to find the area of a triangle?
Base times height.
Okay. Tell me again.
Base times height, half.
Okay, 1/2 based on type.
Yeah.
That's the basic formula. To find the area of any triangle, 1/2 based on type. Just out of curiosity, what's the basic area formula for a rectangle? You'll find the number of square units area of a rectangle. Length times width, or based on type. Triangle is 1/2 based on type. So if with those numbers, that student in middle school would say, oh my goodness, I know I've gotten this correct on the test, because it's merely 1/2 of, look at this guys, this is like C, this is like A, let's call it, this is like B. Put capital C here, capital A here, label it, and B here. I just merely put in my numbers here, 3, 4, I think we end up with 1/2 of 12. Is that 6, guys? Did I do it quickly? I did it real quick. Is that true? 1/2 based on type? What's acting as the height here, by the way? What must be acting as the height of this right triangle? Because I put in a number for it, it says 1/2 based on height, and if I turn this around and make sure everything matches up, 4 coming first, then 3, what's acting as the height here? Is that side B? Is that the perpendicular? Acting as the height? So if I have the height staring at me, just put it into the formula 1/2 based times height, and I see some looks on faces right now, say, Professor, please put lots of these on the final. Just ask me to find the area of the right triangle and have it labeled for me, Professor, and I'll walk out here on Monday, the 15th, smiling. Now, you want to see something like that? Yeah. What am I going to see? You're going to see this. On the side here, with that in mind, 1/2 based on type area, you're going to see, I'll mark it here straight, this. You're going to see a triangle that's a non-right triangle, like this. Does not contain a right angle. And I will label it like this. Capital letters for the angles, lowercase letters for the sides. and ask us the best we can to express now the area of this triangle. Where the standard area formula is 1/2 base times height. For any triangles, 1/2 base times height, 1/2 base times height. What's missing on this one? I got a base, there's my base. That's my base there. What's missing? I don't see a perpendicular. Do you see a height? Like on this one? And a height. The height's missing. Now, can anyone tell me what like I have to do here if I want to find the area of this, and they call this an oblique triangle. Non-right. Throw that word out there. Oblique, almost like an oblique asymptote. Oblique triangle, non-right, has no right angle in it, but yet they're asking to find the area. What would you have to do? And still you gotta use that standard 1/2 base times height.
Split it into
Unit.
the middle,
Come again.
just split it down.
Yes, you do. Isabella says, Professor, put a height in. She says she wants the one that drops down from the top, like this, and label this as your height, your perpendicular. Now I've got a height. And if I say now with that height in there that she suggested, what would be the best way I can express the area of this triangle using that standard formula, 1/2 base times height? Be very careful. It's 1/2, standard formula. Base, yes, I have a base. Guys, I have a label as C, goes all the way across. That is C, 1/2 C. Times the height, she told me to do. 1/2 base is C, and the height is H. Did I express that correctly? 1/2 base times height. Woo! Now, that's number one. That's the area expressed with the help here. Now, I want a clever student to tell me, and watch what's gonna happen. I'm not leaving this triangle yet. Can anyone tell me what the sine of angle A in this small right triangle on the left? What could I express the sine of angle A as in that little small right triangle on the left? If I use, now erase my definitions, opposite over hypotenuse. Sine of angle A, right here, what would the opposite over the hypotenuse look like in terms of letters? Anyone? Anyone at all?
H over B.
There you go. H over B. That's the opposite of the hypotenuse. Now, Michael, with that said, I'm going to express like this. B sine A is equal to H. Let's do a quick cross multiplication. I got the H by itself. Number three, anyone now be clever and tell me what's the best you can do for sine of angle B in the other small right triangle on the right? There's another small right triangle right here. I'm going to use that same definition from middle school. Sine is opposite over hypotenuse. What would the opposite over the hypotenuse look like on this one for angle B? Looks like it's H over A. And if it is, I'm going to call it this, A sine B is equal to H. Now watch what I'm going to do. Watch carefully. I will now go back to number one, my standard formula, 1/2 base times height, and rewrite it in one manner like this. 1/2 C H. I have a substitute for H. Step 2 says if you like to substitute H with B sine A, go for it. Put that in a different color so you guys can see it. So I'm going to substitute H in a standard formula with this. B sine A. Did I do that, guys? Is that a substitute for H? Then a student may say, wait, Professor, if you do it, could you not have replaced H with, there's another substitute for H. Down here, why not replace H by this one? I'm gonna try what that looks like. It's still 1/2 C. And now my replacement for H is from number 3, A sine B. Now close this up. So right now, guys, at this point, we have 1/2, right like this, 1/2 BC sine A. The other one with the other H replacement, 1/2 AC sine B. Do we agree? Try to find the area. Okay, here goes, guys. Let me go back to my triangle. One way to find the area of that oblique, non-right triangle would be to use this formula. Or another student may say, Professor, could I use this formula? Either one's going to lead you to the same answer. Now we take a look at the triangle. This first one says take 1/2 of B times C, these two sides, times the sine of angle A. That's where angle A is located in reference to these two sides. Where is angle A located in reference to those two sides in this version? Is A located between? Does A fall between? Another student may say, Professor, you mean I'll get the same answer if I had numbers to work with for the area if I use this version? This version says take 1/2 of A times C, these two sides, lengths of these two sides, times the sine of angle B. Does angle B fall in between those two? So what does it come down to? Take 1/2 of the product of two sides of a triangle times the sine of the included angle. Now, I don't care what you work with, as long as you get that to work out for you, 1/2 product of two sides times the sine of the angle that falls in between. Now, can someone in this clever class tell me? You can't see it up here. Well, you can see it, but it's not as clear as the other work. Can someone tell me another way to find the area if it comes down to 1/2 the product of any two sides times the sine of the included angle? Is there one more possibility that I can use it there to find the area again? I have it here, these two sides, these two sides. Can someone see another version that I could use based on this triangle? 1/2 the product of two sides and the sine of the included angle. What's another possibility? Definitely a 1/2. Definitely a 1/2. Now I need two sides. What two sides have I not used up here? That might be another possibility. These two sides. Is it true? I've used these two sides, A and B. So 1/2 the product of A times B times the sine of, now what angle is included between those two sides? Angle what? C, was it? Is it true? So if I ask you to find the area of a triangle, Aaron, I don't care whether it's a right triangle, oblique triangle, you may use any of these. Set it up and you'll find the area. The number of square units in that. What I want to do though, that's the area. That's the way to find the area. Right quickly, hang on guys. I'll watch my time here. Let me throw in something, this is me. Let's say side B was, I'll throw a number at you. Let's say side B was 6 units long. Let's say side C was maybe 10 units long. And let's say angle A was, I'm throwing these numbers at you, 30 degrees. And ask you to find the area of that triangle. And you said, Professor, it comes down to merely area of that triangle. The numbers you gave me is 1/2 times the product of those two sides, 6 and 10, times the sine of the included angle, and I threw in 30, included between those two sides, and do a calculation, you got the area. With me, guys? So I must give you the measures of those two sides, whatever those two sides are, I must give you those, and the angle. Just finish this up out of curiosity, I see, 30 times 1/2, I guess 15. 15 square units for the area of that triangle. I think sine of 30 is 1/2, isn't it? Did I do the math correctly? That's the area. Woo! Who would have thought? And by the way, did I already all the way there? I didn't erase it, thank you. Now you go back to middle school before I do this. We found the area to be what, 6 back here? Earlier for the middle school problem? This is the right triangle. Suppose I apply this business on that triangle there, which says, Professor, now since I know that, could you have not found the area of this middle school problem of taking 1/2 of, guys, here we go. These two sides, 3 and 4, times the sine of the included angle, the angle caught between, oh, that's 90 degrees. If I chose 3 and 4. That's true. So we end up with 1/2, 12, and look at that, sine of 90, you know when the unit circle is 1. Am I going to end up with 6 again? So I could even use this 1/2 business and the sine, even on these basic triangles. With me, guys? That's to find the area. Now, before that time catches up with me, before we close this down, chapter 7 is closing down, I want to do this. This is beautiful. No doubt you find the area now. But I want to modify this a little bit. First, I'm going to clean it up a little bit. Now, guys, first I add a mark that this, all this, is for you to find the area. That word out here. If you have to find the area of any triangle, try this. Now I'd like to do something with those to find something else. I'd like to go back to that blocked off version and cleaned up. Guys, I'm gonna multiply everything by 2. Get those 2's out there. And on the side here, have now this to look at. Multiply through by 2 to clean it up. And here, now the 2's are gone. I think everything's copied down correctly. Woo! And then one more step to get something else. Take that result and divide everything by this expression, A, B, C. Everything. What's going to happen? Here the B's cancel, C's cancel. You're left with sine A, angle A, over lowercase a. The next one, A's cancel, C's cancel. You're left with sine of angle B over lowercase b. The last one, A's cancel, B's cancel. You're left with sine of angle C over lowercase c. This is a result coming from that area formula up there. That gives me something else. And some of my students may know what that is. You've had a little trick. In fact, I think it's on your handout. They give a name to it. This is known as the law of sines. Chapter 7 is closing down quickly. Oh yeah, I see why they say signs. I see all signs there. This is law of signs. Okay? Now, watch my time. Michael, did I have just one example of an application of use the law of signs?
How to solve the given triangle.
Okay, and did I have a triangle drawn for the students?
No.
Or I just labeled?
Mm-hmm.
Okay, here we go, guys. You got to see this. Okay, this is known as law of signs. It came from this. Don't confuse the two. This is to find the area. after I've modified it, just to find something else on the triangle, called law of sines. Okay, let's see what this is, and by the way, I should point out, right now, that more than likely, Michael, when you read that to me, this triangle probably is an oblique triangle. Okay, read that to me. Given what?
Given that capital A equals 40 degrees,
Okay, A is 40 degrees.
B is 60 degrees,
Capital B, 60 degrees.
lowercase a is 4.
Lowercase a is 4,
Yes.
and then find the missing parts, I guess.
Yes, and the area.
Oh, and the area, okay. That'll be the list of missing parts, guys. Capital C is missing, but that we'll find out quickly. Lowercase b is missing, and lowercase c is missing. Now, if I can get this done, we'll take a break. Woo! Now, I would, this is me, I'm gonna sketch it, even though I do see one part there that's missing, easily answered. Guys, I see right now, this is not a right triangle. Looks like this. Now, when I say oblique, you guys who know your vocabulary, that means it could be an acute triangle. All the angles inside less than 90, or it could be an obtuse. One angle inside bigger than 90. I'm gonna label mine like this. It's up to you as to how you want to label. He gave me A is 4, that would be over here. B is missing. C is missing. Angle A is 40. B is 60. And I know, and you know quickly, that leaves angle C to be 80. So put that in. That's about it. Now, let's try to find the two missing parts. Then we'll take a break. Mr. Park and class, if you see one of these on the final, I must make sure that this angle is going to be something that you work with, like maybe 60, 45, 30. So you would not have to use a calculator. My particular example today, though, Parks going to have to help me out here. Okay, guys, look at this. That's my triangle, oblique triangle. To find either B or C, now I'd like to apply this law of sines if I could, in an attempt to find those missing parts. Anyone tell me if the law of sines, and closing down, give me a match that says I can match sine A with A. If I can, that would be, in my case, sine of 40 over 4. If I wish to start out like that, I can try it. And we got that. Sine 40 over 4. Now let's do another match with this law of sine. Sine of what over what?
60.
Sine of 60? Okay, I try 60. Now, if she gave me 60, sine of 60 over B. That's the match. I'll stop right there. That should be enough to set this thing up and find out what the length of side B would be. Guys, we'll do a quick cross multiplication. This is B sine 40 is equal to 4 sine 60. All right, I wish I'd give you like a 30 degree rather than 40. Because I'm going to have to call on Mark here. Divide this by sine of 40. And if I divide by sine 40, these cancel out. Which part? Can you take 4 sine 60 and divide that by sine 40 and tell the class what is that close to? We're closing this down.
5.4.
5.4? 5.4. Okay, that's B, roughly 5.4. Now I'm looking for C. Could I use C squared is equal to A squared plus B squared now, since I have everything to work with? I see heads nodding yes, and then you would be with me during the summer. Why can I not use C squared is equal to A squared plus B squared? This is not a right triangle. That Pythagorean theorem works only for right triangles. So C squared is equal to A squared plus B squared is out. This is an oblique. So somehow a student must tell me that, maybe use this law of sines again, match something up for me, in the attempt to find C. What should I try? Use some matchup like you guys did for this one. And I'm looking for side C. What would I try? For the law of sines. I would try, just think you guys, I'll get you started. Sine 80 over C. That's one match. And then give me a possibility for another match.
Sine 40 over 4.
There you go. Sine 40 over 4. Now suppose a student had given me, besides sine 40 over 4, they said, no, Professor, how about sine 60 over what? Well, you just found B, Professor, over 5.4. Okay, that's a little risky, because if you miss 5.4, you're gonna miss the other one also. I like this, guys, let's do a quick cross multiplication, I'll clean it up for you right quickly. You're going to end up with C to be equal to 4 sine 80 all over sine 40. I would not do this to you on a test. 4 sine 80 divided by sine 40. Mr. Park, guy, what's that close to?
4 sine 80 divided by sine.
It's right here.
6.12.
How much?
6.12.
6.12.
Yeah.
So this is approximately 6.12. And we're done. We're hoping those are correct. There's no way really to check this. There's not much of a check there on this. Okay, guys, you with me? Now see the time. Michael, do I just have one more little item on there? I notice I did not find the area. I may have found the area. I may have found that. But did I have one more item to look at on that handout?
Law of cosines.
And that will be chapter 7 finished. And before we take a break, I'm not gonna do it though. See how class, and I'll make a sketch of the triangle, triangle. It measures, and I'll quickly do it up here, that I gave you for an example for law of cosine.
Lowercase a equals 2.
Lowercase a is what again?
2.
2, okay.
Lowercase b equals
3,
3. Capital C equals 30 degrees, or 60 degrees.
60 degrees. And that's all I gave you.
Yes.
Okay. Woo! There we go. I told you how you label this. We said that for you. He gave me A is 2, that's over here. B is 3, that's over here. And this is 60 degrees. Oh, the angle falls right between those two sides. Michael, that's what you're saying, right?
Yes.
Okay, and they want you to find all the missing parts. Now, we're gonna take a break, we're gonna do this after the break. Guys, there is no way that you can just sit there and tell me what the other two angles are. They gave me 60, but I cannot, just that one angle given to me, I can't find the other two here. You try. Can anyone tell me what the law of sines, if I go to law of sines, maybe a little match with the law of sines like we're doing here, in an attempt to find maybe one of the missing sides? Does anyone have a match here that you'd like to try? If you tried the law of sines, you may say, Professor, try sine 60. Well, of course, I can write sine 60. Over what? Should be over this side down here. So that side's missing. Can you say, well, try sine B. I don't know what B is. Right? Sine A, I don't know what it is. You can't solve this when you use the law of sines. And therefore, they have another law called law of cosines. And when you get back from the break, that's the way I'm gonna finish up chapter 7. Okay, guys, any concerns here? Woo, woo. We're class, math 2 is almost over. I'm gonna miss you guys. I'm gonna miss you. And some of you've already told me the professors you're gonna have. And I know all these professors, we talk. You think students talk? Professors talk. Yeah. I'll find where you are. I'll ask that professor, so-and-so, how's Michael doing? Oh, Professor Landry, Michael's failing. How's Erin doing? Oh, Erin, she took the class again. Oh, no, I'll go find you. After all this hard work, oh, no. Don't be words like that. Okay, guys, take a 10-minute break, and then we'll